Okay. Okay, so what you see here are basically lines of code, right? As you know from data frame, essentially we have 4 different quadrants in our studio. And these 4 quadrants basically show 4 different things. So you have on the left top, you have the so-called script. The script essentially allows you to write your code and to essentially formulate the things you want R to do. You will have the possibility here to use all the functions that R has to offer. You can build data frames as I'm doing here, and you can do analyses and perform actions on your data. This script can essentially be saved and opened and treated like every other file on Windows. So actually you will notice I'm today on a Windows computer, so please don't so that for those of you that are Mac users, this may be a little bit different to see, but in overall, RStudio should be entirely the same between the different operating systems. So this script essentially is what you will be working with. So see it as sometimes an instruction sheet for R that essentially R will be using here on the lower left quadrant. The lower left quadrant basically shows you here the so-called console. The console is essentially the core of R. So you basically have R and RStudio. R and RStudio essentially are to some extent working together, where R is basically the processing core piece of R, and RStudio is basically allowing for a user-friendly interface. So it's so to say, it's essentially nothing else but a so-called compiler. So those of you who are computer savvy and kind of inclined to do computer interesting things and computer related things, you will know what a compiler is. And essentially this compiler essentially will use R to perform actions on data that is here on the right upper quadrant in your so-called environment. So when you look here at this environment, it's currently empty. What this means is that there's no objects involved right now. So just as a quick background to that, R is an object-based, line-oriented statistical software, statistical programming software, which means that you basically will be creating objects in your environment that you will write lines of code that are essentially dealing with these objects. So when we go now into the script, and here on the right lower quadrant, this is less important essentially. What will be important is that you will be seeing plots here. So this is where you see the graphs. And here you also see your packages. So in case you need to install a package, and we may do so at one point later on at one of the later practice labs, you can install packages here. The way you would do this, you go and install, and here you look for the respective package that you want to install. So here, for example, this would be the package do by, which is a very good package for data aggregation and characterizations of descriptive statistics. So, but what we will be doing now is to load these data frames here on the right in our data environment. So we have essentially here the same data frames as those that we discussed in class. So we have here the Stroop data example. You remember the Stroop data between congruent and incongruent data. Then we have the Volcano data example, which was essentially where we worked with grouped frequency tables, and we built histograms. Then we have here the athletic performance table. You remember that athletic performance increased with hours of deliberative practice. And lastly, we have what we discussed last class in our central tendency lesson on Monday, where we essentially talked about central tendency in the Charity Navigator score. So now what are we doing with this? So let's go for the first example. So we essentially we are now starting the first line. So whenever you see a line which has a hashtag here in front, this essentially indicates that there is a hashtag out line, which essentially implies that this line will not be run. So this is purely for you to document it. So if you run this line, and running lines is done with Control and Enter, or alternatively here on the right upper tab of the script with the command run. So if you run this, essentially you will see that nothing happens. So this is just for you to comment and to help your future self to essentially remember what you did in this respective exercise. So what this code here means is rm list equals ls. This essentially is nothing else but cleaning the environment. So rm is the remove function, which essentially removes everything from your object or of your objects from the environment. With list, you're essentially indicating which particular objects you want to be removed. And ls is basically a way to depict whatever is present in the environment. So what it means is essentially remove a list of all objects that are currently in the environment. So this cleans the entire environment. So running this essentially will clean the environment. Line number 3 is again commenting out, and line number 4 creates now our data frame. So this data frame essentially contains the 3 variables that we also have seen in our Excel spreadsheet. Right? So it's basically, it's the R way to show this data, and it looks in principle the same as it did in Excel. So now to demonstrate you the RM code, if you run line 2 now, essentially you see that on the right from the environment, this has now disappeared. So if we're running this again, we're basically seeing it reappears. And you can already imagine that this is the charm of R, and this is actually the beauty, because whatever mistakes you may have made with your object, you just go a line back and you basically rerun parts of this code. So this also makes it easy to document whatever analysis you did, and secondly, most format also allows you to rectify mistakes that you did, and you always you can retrace your mistakes, and you can basically rectify them and run the code again, and essentially see what the real analysis then shows. So just for you to see, so we have here the exercise asks for count those that were faster than 15 seconds in the congruent assessment. So this is now being done. So I'm just copying this over from the completed spreadsheet, and you will find this as an announcement in your canvas. So if we want to count, there's a function that is called length. Length will give you the length of any object you're basically assessing. So if you want to see the length of, let's say, this variable or this variable, congruent or incongruent, you essentially will write df underline m2, and this is our object. And with the $sign, you can basically address sub-components or sub-objects, aka variables, in your data frame. So if you want to quantify the length of congruent in your dfm2, you essentially, it will count the length of your congruent variable. So this length essentially is here 24, as you can see, right? So if you want to have a count of only those that are 15 seconds, you will need to be more specific. And the way you be more specific to R, you create here brackets following the variable name. And you're indicating again dfm2, because this is the criterion you want to imply. So dfm2 congruent should be smaller than 15 seconds. So these are the second entries of the Stroop test, as you remember. So we only want to count those that are shorter or faster than 15 seconds. So we do dfm2 congruent smaller than 15. And if we run this line of code now, we see that this is essentially 15 seconds now. So I'm dropping this in the chat for those of you that are basically continuing and doing this assessment with you. So I dropped this now to everybody, and you can just run these lines of code, and you will then basically be able to follow me along. So this being said, now let's go to the next exercise.
Wait, I have a question.
Are there any questions? Yes, there we go.
What you just sent in the chat, is that different than what you posted in the announcement?
No, it's the same. I just thought somebody wants to follow along. But it is the same code. It's slightly different because I'm doing the steps in between, right? I'm doing the intermediary steps. The solution I posted on R is basically just the final version. So I mean from a didactic value to kind of allow for you to follow along with the exercise. Yeah. So, but it's perfectly fine. If you just post what I posted on R, that's on the canvas is perfectly fine. So now if we copy paste now from practice lab 1 completed into the actual exercise, and we're doing this also for incongruent, we essentially will get only the incongruent entries, which is incongruent. Okay. Oh, it was really 0. Okay, so the length of those where congruent is shorter than 15 seconds have been 15 for the congruent variable, and for the incongruent variable it was only 0. So there was none. So this means that congruent was substantially faster to be solved, which we have seen in our own experience, right? So if we want to look now for the average and compare the averages, it's essentially the same exercise, right? So we did in the lab, in class, we did calculate the averages. And also here, if we use the mean function, we essentially have the same situation. And we see just the same as in the Excel spreadsheet. We see that the mean for the incongruence is substantially larger than the mean for the congruence. So, any questions to our Stroop data example? I think that was fairly easy, right? Because then we could move on. We are now looking for the volcano example. And the volcano example is a little bit more complex. Because what we need to do for the volcano example is now a little bit more involved. So, oops. So now we want to build a frequency table with a count from 1 to 17. You remember the frequency table that we built in R, right? So we use R in Excel. That essentially was doing nothing else but counting each country that had a certain number of volcanoes contained on its soil. So for this very reason here in R, we're building what is called a table. This is a data frame, just like the data frame I have designed here for our volcano example. And we can look at the volcano example. You remember there were 55 entries, right? And we excluded 4 of them, which were skewed and which were substantially larger. So we have now these countries lined up. So Antarctica contains 1 volcano, Argentina 1, Australia 4, the Azores have 3. So this is the same list that we had in Excel. So F table is now a table that basically contains a count and the frequency. The frequency is the number of countries that contain a certain number of volcanoes. So what we're doing here is we will need to count. So if you want to know the number of countries that have, we're doing lengths again. The length function is the function that allows you to count countries, so DFM3 country will essentially be 55, right? So we have 55 countries. So now remember, for the Stroop data, we had, if we wanted to count at something, we needed the brackets. So the brackets is now DFN3, and we, oops, brackets. So DFN3 were volcanoes. So now we're having a different criterion, right? Volcanoes. No, count. Volcanoes. Count. So we are counting now countries where the count of volcanoes was, and this is a specific way of doing it for in R. You do double equal signs that basically prompts R to search for one particular value. So now with this command, it will count only countries that contain one volcano. And if we do this length, we get now 14 countries contain one volcano. And now when you look at this code here, so this is a little more complex. So we have here length, DFM country. This is the same as we have in this line. DFM3 count, which is the same here, double equal sign, F table count. So F table count is, as you remember, we have here F table, that's our frequency table. Count is from 1 to 17. So now what we have here in a so-called for loop, it will count from 1 to 17, because these are the entries we want. So 1 to 17 are the counts we want to essentially evaluate. So if we're doing now I, so it will run it within I as a loop, it will run everything within this curly bracket for 1, for 2, for 3, and these numbers and these repetitions, these iterations of this code within the curly bracket will be assigning a value from 1 to 17 to I. So if I do I equals 1, so this is the equal sign in R, as you know from data camp. So if I do I equal 1, this count will essentially be 17 or 14. See? So now I equals 1 because I have manually given it a 1. And this command will now run for the same numeric value as here. And what I do with F table frequency, so F table frequency is essentially NAs, because this is the second column here, right? And if I say I, it will take the first row of this particular column and it will assign to this cell, so frequency, in variable frequency, it will take the first row and it will assign the numerical value of this line of code, which is 14. And this is what it did here. It assigned 14. So now if I run this now 17 times, it will basically go row by row by row by row, assign the respective value to I, and will run the respective code for each of these numeric values. So if I'm running from line 22 to 25, so from 4 down to the curly bracket, I will essentially, and I'm dropping this in the chat, I will essentially run this code and I will basically populate that table. Oh, you need to deactivate the I. You need to hashtag it out. So if I do this now, the frequency table essentially looks now that way. So it's 14, 12, 4. So it went one by one by one by one. It went through and it counted all the countries that contained the respective count of volcanoes. So it ran that through, and if I run this line of code, it will calculate the percentages, just like it did in class. So these are the percentages of the overall countries that were assessed. And ftable, if I only run ftable, here's a line, it will just basically depict this table. Makes sense, right? And it's a very neat way to essentially employ R for your purposes. Any questions on that? It's fairly simple, right? It's like the for loop is a little bit more involved. It's a little harder to code, but it's overall, as a concept, it's considerably easy to grasp. And with that code of that for loop, you have the tools at hand that you can iteratively do whatever command you want R to do. So it's a very powerful code. So I'm seeing here, just do that by me, okay. Well, what aspect doesn't it do, Trina? If you go on your, did you hashtag out the one, the I? Maybe that changes the situation. I'm dropping the entire thing again in the chat. Oh, okay. No. So I'm dropping the entire thing in the chat. That should solve the problem I have. Oh, I don't know. So it should run. Let me know if problems, we can resolve this after class. Okay, so if no questions, then let's move on to number 3. Did you solve your problem, Shana? Was the code able to solve it? Still not? Let's do this after class. Let's chat after class about it. I'll show you what to do. Okay. Okay, then we have athletic performance. So we have here DFM4, and this is the non-completed code. Yes, Abigail.
I'm just curious, are we supposed to be like writing this sort of thing on our own? Like, what should we be doing right now?
Right now, just listen in. But so what the outcome essentially is that I want you to do, and this is all you're asked to do. I want you to save this code. I want you to keep it on your desktop or anywhere where you will remember it. And whenever you're being exposed to do statistical analyses, I want you to remember that there was one teacher that basically showed you how to code R. And maybe you're going to choose R for your purposes, and maybe this code will one day come handy for you when any time in your further education, you will do statistical analyses. So what I will be torturing you for this class is you're doing essentially this. You get the code from me, you go into completed code, you press Control-A, you select the entire script, and you press Control-Enter. You run the entire code. This is all I want you to do. And you're selecting everything that R has produced here. So you're selecting this, you press copy, you go on your desktop in your folder, Practice Lab 1, you create on your desktop folder Practice Lab 1, you create a text document or a notes document on a Mac. You're labeling this with your name. Let's call it Practice Lab 1, Raymond for 2021. You're labeling it that way. You open the text document, and what you just copied in your R Studio, you're basically pasting into this text document, and you save it. This text document is your deliverable for the practice labs, and this will be the same for all 5 practice labs. This is how easy you can save or you can gain 50 points in this class with the practice labs. It's not difficult, right? Would you agree, Abigail? It's easy earned points. That's my point. So the idea is really that I want you to have those codes, and you may never ever look at them again, and that's fine by me. But maybe one day it's gonna come handy, and you're gonna be happy to have them. And that's what I'm counting on. And this is why I'm doing this exercise with you. Okay. Any questions on that, Amira?
Yeah, when I put in the new code, when I put in the code, it keeps on giving me error messages. I'm not sure what I did wrong.
Well, there shouldn't be any. If you just run practice lab completed, does it run through without a flaw?
It does the things, but then it says error object df_m3 not found.
Did you run it the way I showed you? So you basically you click into your code, you press Control A, and now you press Control Enter. It should run. It's a standalone code. It should run alone. If it doesn't do it, then we need to revisit this after class. Then something is off.
Yeah, I don't know. I did that, but it still gives me it runs the rest of the code, but that's the only part that doesn't work.
Okay, just go below, go on the console, press Control L. Control L will clear this all. Now run line 1 and 2, clear your environment. Make sure everything is clear on the right.
Yeah,
did it work so far?
Control M or Control N?
Control L.
Oh, L.
L, like Leo.
Okay.
Yeah. So now this is end. Now click in the script. Run line 1 and 2. That clears your environment here on the right. And now click into the script and press Control and A. That should select the entire code. And if you press Control and Enter now, it will run the entire code. And that should go without a hiccup.
Yeah, that worked. Thanks.
Okay, perfect. All right, so this is the practice lab. Whatever issue you may have, please stay on after class and we'll talk through that. Okay? Happy to give more insights. Okay, any further questions? There's not, let's carry on. Okay, so we did an iterative loop. An iterative loop is whatever you will be programming in your lifetime. If you will do analysis, you will need to know what iterative loops are. This will be true for even the syntax and SPSS does that. So those of you that are going into psychology, you will be programming SPSS. I guarantee you that. Those of you who are going more in an analytic route, you will likely program SAS. SAS will also need you to program iterative loops. If you, well, I hope, sincerely hope, opt to program R, you will also use iterative loops. So iterative loops are really super important. And this is like the simplest iterative loop that one could think. It's a little bit complex with the eyes and the way the code is put, but it makes sense intrinsically. So if you are somewhat analytically inclined, I think it's a nice code to play around with. So if no more questions, then let's do example 4. This is building a data frame with the athletic performance data. If you remember this plot, we had that in module 4. This was basically showing the association between athletic performance, labeled as AP here, and the hours of practice put into your, to improve your performance. So this basically gives you one entry for a total of 21 participants in your study. And you will essentially now, close all of this. So if you go on the completed, so we see here now that scatter plot that we're meaning to show. So build a scatter plot displaying athletic performance on the y-axis as a function of exercise hours on the x-axis. So you want to build now a plot. And the plot is always done with the plot function. So the plot function essentially is dfn4 hours. So this is our x, the first entry before the comma was in the plot bracket here, the plot parentheses here. The first entry essentially is the x. The entry after the comma is the y-axis. So we have here x and here y. And if we run this, we essentially produce now our first plot in R, which you can zoom in and you can display a little bigger. You can, in addition to that, you can also beautify it a bit, and you can say, okay, so I do xlab equals, with quotation mark, you can change hours of deliberative practice with ylab, while lab for labor, y lab. You essentially can change labeling of the axis performance. This is the athletic performance. And you can, in addition to that, and you don't have to do this, but abline, and this is now a little bit more complex. LM is a linear regression model, which we haven't done yet, but just for the sake of showing it, if we're doing a regression model now, so this is now athletic performance as a function of dfmf4 to the, okay, now we can even fit a line through that. You remember how we did the line, and this shows now the trend within time. So you put more hours of practice in, you basically get a higher athletic performance. Okay. This is a nice little exercise to show the first plot. And this is basically all we need to do. Any questions on this? It's easy, right? That wasn't too complicated. Oh, no, good. Thank you.
I have a question.
Yes.
So it seems as if our studio or R that we're using, at least for our sense, is that it seems very similar, like we're getting this similar, we're finding the similar things that we would use Excel for. Is that accurate, or is that like?
It's 100% accurate, and it's actually, it needs to show the same things, particularly when you do the calculation, it shows the same things. The real beauty of R is that in Excel, when you're selecting the columns and you have the columns and you put in these various formula in the cells, if you have a change in your data, for example, let's say you're conducting a study and you're quantifying athletic performance in 21 respondents. And now suddenly, I don't know, your research coordinator found out that 3 of the entries were wrong. In the meanwhile, another site also studied an additional 10 participants. So everything changes. Your data is an entirely different data set at the end of the day. You would need to do all your calculations again in Excel, right? You need to do the whole thing over and over and over. So this is time consuming. With R, you program your code, and your code is gonna be the same for the rest of the days. And whatever data set you use, as long as the variable names are the same, it does the exact same analysis within R. It shows you the exact same results, and you can export things as PDF. You can automatically create PDF files with reports, with graphs, and then you have like this whole realm of capabilities at hand with the tip of one button. And it's a super powerful tool. So I don't know to what extent you already know where you're going to go, but if you go into the realm of analytics or realm of research, R is definitely the tool you want to use. I guarantee you that. It's like I've worked with R now for the last 14 years, and it's a wonderful tool. It makes life so much easier. And I've written like 10,000 of lines of code, and it makes your life much easier. Does that answer your question? And yes, the results should be entirely the same. It would be utterly concerning if the results were different. So they have to be the same, right? It's just what's really great is like just graphing. The graphs that you can create in R with such simple codings. You create beautiful graphs. You export them as a PDF. You can send them off to a journal after you when you're writing a paper. You can send them off to a journal just like that, and you don't need to worry about anything anymore. So it makes life much better. So I hope this answers the question. Yeah, but in principle, you're doing the same thing. So if you really just want to do simple analysis and like simple stats, you might as well go with Excel. It's not that I never use Excel. I use Excel quite a bit. But yeah, R is just much more versatile, much more powerful. All right. If no more further questions, then let's carry on. There was, oh, okay. Yeah, but we'll look at it later here. Okay. All right, now we have the data frame with the charity Navigator score. And we remember that, so let's copy the whole thing over to get going. We only have 40 minutes left. That's the charity Navigator. And here with the charity Navigator, we essentially were building a histogram. And that was the histogram we saw, right? That was the histogram, which was like somewhat normally distributed after exclusion of the outliers. And here's the mean. And this is the mean of 19.33. So I don't know whether you remember the number, but that was the number we also had on Monday. Then we have the median, which is 90.15. And you remember the calculation of the median, right? So we sorted the data and we looked for the middle number. And if it was an even number, we kind of, we averaged the middle two numbers. If it was an uneven number, we only used the middle number. Then we have the standard deviation, which we calculated by hand. Again, one line of code, one click of a button. You have the standard deviation right there in front of you. Those of you that remember standard deviation, standard deviation squared is the variance. So this is the variance. We can also write it in this format. We can also, so there's a var function, just like in R. So we essentially can do this that way. We confirm our own calculations. And then we can do the quantiles. We can calculate the quantiles. So you remember the quantile Q1. Q1 is 25th percentile. So 25% of all entries are smaller than this entry. And if we're running this, we're seeing the 25% are at 87.9. So that's approximately here. If we do Q3 with 75th percentile, we have 94.2. We can also do this that way. We can do summary, df n5 score. That will give us the same thing. So this is first quartile, third quartile, same values, mean, median. So you can also do that. And that's the beauty, again, the beauty of R. It gives you so much good overview, and you can address each of these components, but just again, this becomes an object again, right? So now if we say now summary, summary table is now summary, we can assign this to a table. So summary table becomes now essentially what we have summarized here. So you can assign everything to an object. And if you want to extract something from this object, you can just, again, use the brackets and you can address everything in the bracket. So you can say summary table 3 is here, 1, 2, 3 is the median. And you can do arithmetic exercises with it. So if you do summary table, so this is the IQR. You remember the calculation of the IQR? So the IQR is here 6.3, which is third quartile minus first quartile. So this is 94.2 minus 87.9. That's 6.3. If we do summary table 1, 2, 3, 4, 5 minus summary table 1, 2, 2, and we again, so we need to do this as numeric, that it becomes a numeric. That's a little bit of a subtlety of R, that's a little different. So if we make this as numeric, we get the same value essentially shown and this is again 6.2. So we have now extracted it from this object summary table, and we have done the arithmetic formula of subtracting the fifth entry in summary table, which is the Q3, minus the second entry, which is the Q1. So, and this brings me to the end of it, and that was our first practice lab. And I am just really asking you, so basically press Control, I repeat it, and this is, so please deliver exactly that. You don't need to do more than that. You go in the script, you press Control and A. You press Control and Enter. You run the whole thing through. And now you just select everything in there. Please, okay, first Control L on the console, then Control A in the script, selecting everything, then Control Enter to run the whole thing. And then just go down there in the console and select the whole thing. Oops. Select the whole thing. Put it in a Word document or a text document that you label Practice Lab 1, your name, and the semester. And submit that to the practice lab, and you have made your first 10 points. As easy as it could be. Yes. Hi, Abigail.
Hi. Do we have to also submit that graph or just the output?
No, don't worry. Just output.
Thank you.
Sure. Well, you can. But, well, just you want to make me happy, then send me the graph, of course. So an easy way, and we talked about plots, right? We talked about PDFs and plots. If you want to create a plot as a PDF, which may be the first time you're doing that, and maybe the last time you're doing it, but maybe not. Maybe it's the start of you knowing now how to do plots, and you want to do more plots. So you can go on plots here, and export allows you to export your graphs in whatever format you want to have it. You can choose the directory, and you can save your plot here that looks just the way you have programmed it. You can save this PDF, and you can create a PDF plot. So that's a very elegant way. So in case you asked in one of the classes to provide a graph, you can kind of shine bright by submitting a PDF. So it's just elegant. Okay, in any way. All right, so I think this was all I had. If there are more questions, I'd be happy to stay on a little longer. Otherwise, I think we're done for today. Here it's 1:30 at night, and I guess I'm gonna hit the hay. Okay, so thanks for coming on. Hope the quiz wasn't too tough, and I see you not next week. I see you on the 18th of October in person in class, our regular time, 6:05. Please, good luck with the homework, and don't forget the practice lab. This is due on the 14th.
Thank you.
Thank you.
Have a good night, man. Bye.
Thank you.
Professor,
Yes.
the homework is, I was trying to press the link to it and I couldn't access it. It might just be my computer, but it says it wasn't accessible.
Now that could also be. So we transferred. So there was a Canvas transfer that was moved over. It could be that the link is broken. Thanks so much for telling me. I'll look into that right now. Thank you so much.
Okay. And I also have a question about the quiz.
Yes.
But it's like a specific question about one of the questions. So I can email you, I guess.
It's probably more effective. Is it? Well, I will, and I should have said that, and I think I said that in the past. I will go question by question by question through all of your questions that you have answered. So in case there's a question where you kind of wrote something out and it wouldn't mark it as correct, I will catch that one. If not, email me, let me know, and let's have a conversation about it. Happy to come on anytime. So
Thank you. Have a good night.
Thank you. You too.
Hi, Professor.
Yes.
I had two things. One, when I went on the homework, I just wanted to see what it was. I clicked on the doc, and then it doesn't open. It says like page not found. So I don't know if
Yes,
that's.
Elena said the same thing. Yes, I will look into that.
Oh, okay, but that's
Yes,
not due. When is
Thank-
that due?
No, that could be a glitch from Canvas, and it's ultimately my responsibility. So I have to look into that. Thanks
Okay.
for bringing it up. And
Yeah, and also just to be clear, like we don't have to write any code. We're just copying what you did, running it, copying the output and sending it back to you.
No, by the end of the semester, I want you to be a perfect statistical programmer. That is my expectation.
You're kidding, right?
Of course, I'm kidding.
Okay.
I told you from, and that's what I meant to say on day one. It's like I think many of so our class is decimated, which I don't know, everybody's on decision.
I
So
think
that our
I think
programming.
people just get scared when they hear like coding, even if it's not really coding.
That doesn't matter. Well, it's everybody else's responsibility what they do with fear. But I think I am not asking something that is not achievable from you guys, and I am not asking you to overnight become a statistical programmer. I will not. But it's really, I think it's an investment in the future from my end, because I want you guys to excel. And again, just like I said, it's like you never touch this code again. Fine with me. You touch it one day and you're gonna think about me and you say mentally thank you. That's all I want to achieve with that. Okay.
Okay.
Don't worry about it. Don't be intimidated.
Because I was gonna say, I used to be a comp sci major, but I left it for a reason. So just want to make sure I wasn't going back there.
No. Don't worry.
Okay.
Don't worry.
Okay, well,
I
thank you
make
so
it.
much.
Of course.
Okay, have a good night.
You're
Bye.
welcome. You too. Oh,
Um,
Shayna, how are
yes.
you?
Hi. So